Hi class, I'm going to go over Unit 2 and the 4 sections that make it up here on this sheet. So you can get this sheet from online if you weren't in class. Otherwise, you should have this already filled out if you were in class the day we went over it. So first, properties of matter. There are two categories that we can describe properties. The first being intensive, which are known as the identifying properties. Examples of these would be boiling point, melting point, density, hardness. Doesn't matter how much of the matter you have, but these characteristics will help you identify the identity of whatever you're testing. And then we have extensive. These are things where amount matters. So that would be like mass, volume, length, etc. And so what also is considered an extensive property is the state of matter. As water, think of water. Water can be a solid, liquid, or a gas. So you can't necessarily use that to narrow down what a matter is. So if we look at the three pictures below, on the left we have our solid, which is the most ordered, then a liquid, which has some disorder, and gas, which is very disordered. And if we think about if physical changes are reversible or not, phase changes are reversible. While some non-reversible changes in the physical sense, so I'll put physical changes, would be like tearing or cutting. But talking about solid, liquid, and gases a little bit more, we have to remember our solids have a definite volume and a definite shape, meaning its shape or volume will stay the same. Liquids, however, have a definite volume, but they have what's called an indefinite shape, meaning it will take the shape of the container it's in. And gases, our most mobile, have indefinite volume, meaning their volume can change with the container as well as their shape. So that is 2.1. 2.2, we talk about mixtures. So what makes up a mixture? A mixture is two or more substances. And the key here is that they are physically combined. Not chemically bonded, okay? And so we can split mixtures into two categories. One, heterogeneous, and two, homogeneous. So a heterogeneous mixture is defined as being able to see the different phases. For example, we have salsa or Lucky Charms or a hamburger. You can see what would be considered the different phases. And by phases, I mean if we think about salsa, one phase would be the tomatoes, because all the tomatoes in that mixture have the same properties, where another phase would maybe be the onions. So then we have homogeneous, which is also called solution. You cannot see the different phases. And so examples of this would be even from the Lucky Charms. The phase of milk. Milk is a mixture itself, but it's a homogeneous mixture. Or maybe think of salt water, as you can't see the salt in the water. So that wraps up section 2.2. And then if we go down to 2.3, we talked about elements and compounds. So elements are defined as the smallest pieces of matter, so they cannot be broken down. Another hint is if they're on the periodic table, they are an element. Well, you have compounds, which can be broken down. Into its elements. For example, if you watched the video lecture, you should have seen how I talked about water, which is a compound, can be broken into its elemental components, hydrogen and oxygen. Then lastly, 2.4, chemical changes. And so chemical changes are when a set of reactants create a set of products. So the key with chemical changes, with what has to happen, is that there's always going to be a change. Oops. In identity, properties, or overall composition. But there are some key clues that help us in determining if a chemical change happened. Those being a change in color, a change in temperature, so if your solution gets hot or cold, a production of a gas, so if your solution gets bubbly or foamy, and also a production of a precipitate, which, remember, a precipitate is a formation of a solid. And so this last little section here, this is very important, as the one calculation problem on your quiz will have to do with the law of conservation of mass. So we need to remember what that law is. That is the law that says mass cannot be created or destroyed. And this is very important for chemistry as we do reactions. So this is why our mass of our reactants has to equal our mass of products, because we cannot create or destroy matter. So if I give you an arbitrary reaction, we'll call it reactant 1, reactant 2. So these are what substances we have before the reaction. The arrow means the reaction happened. We create products 1 and products 2. So if I assign masses to each of these, so I will say reactant 1 was 6 grams, reactant 2 was 8 grams. If the reactants have to be equal to the products, we'll throw an equal sign here, and I'm going to tell you we have 10 grams of product 1, and we have to figure out what P2 is. So P2 is going to be like our X in this case. So if we solve for X here, you guys should get 14 on this side equals 10 grams plus X. Therefore, X is equal to 4 grams. Because all I did was subtract 10 from both sides. That's how I got 10 grams. Now, on the back of this table, or on the back of this sheet, there's a table. And I had the kids in class fill this out without looking at the front of their sheet. So go ahead and pause and do that. So hopefully you paused and tried this on your own, because it's only going to better yourself the more you test yourself to see where you need to study. And so filling out this box, you should have gotten no, gas does not have a definite shape or a definite volume. This has to be liquid because it doesn't have a definite shape and gas was used, but it does have a definite volume. Then solid, as it does have a definite shape and a definite volume. And thinking about compressibility, the key here is if it has a definite volume, it's not going to be easily compressed. And if it does have a definite volume, it's not going to be easily compressed. If it does not have a definite volume, it is easily compressed. So gases are only one easily compressed. And here's another equation for you to try. So if you want to pause and try this again, I highly recommend it because, again, this is on your quiz. So please pause now and try this problem. Okay, you should have paused. So if I were to substitute these values in, R1 goes here, so I would have 9 grams. I'm going to go back through. And then you will have P1, which is 8 grams. So 8 grams. And then P2, which is 4 grams. So I'm just substituting each of these numbers in here. So we have our plus R2 and then our reaction symbol. So the one that we're trying to get after is R2. So if we have 9 grams plus our X is equal to 8 grams plus 4 grams, then if we solve for X, we have X is equal to 12 grams minus 9 grams, which is equal to 3 grams. Now your quiz is going to consist of 6 element questions, meaning that batch 1 from quiz 1 is fair game. So you need to not just cram study and actually study these elements. Then there's 12 multiple choice. 7, is this a chemical or physical property, or is this a chemical or physical change? And then your 1 calculation problem, which will be just like what we did here.